Alright, this video is going to be on rational functions. So I was looking at a few questions from the test, and I think there are going to be some major concerns about that. So I would like to just get ahead of that and do some of the examples on the test with you. So these are going to be some of the problems from the test. I'll probably just do the odd ones. Let's look at number 1. Now for number 1, I'm given f of x is equal to x plus 1 on the top of the fraction and x minus 6 on the bottom of the fraction. So what we're going to do is we're going to find the zeros. We're going to find the vertical asymptotes. We're going to find horizontal asymptotes, oblique asymptotes, if there are any, as well as any point discontinuities. Okay, so let's find the zeros first. Now to find the zeros of a rational function, we want to set the top equal to 0. And since there's nothing that we can factor or cancel out first, we don't have to worry about doing any of that. We just go right into it. So I set the top of the fraction equal to 0, and I solve for x. I get the equation x plus 1 equals 0. I can get rid of that plus 1 by subtracting 1 from both sides. And I get x equals 0 minus 1, which is negative 1. So that's going to be my 0. When I write it as an ordered pair, I make sure to put the x value first. That's the answer that we got, negative 1. And when I do write my ordered pair, I always make sure that I put a 0 in for the y value. Because when you're on the x-axis, or when you're crossing the x-axis, your y-coordinate is always going to be 0 there. Okay, so that's the 0. We want to find the vertical asymptotes next. We set the bottom equal to 0 to find the vertical asymptotes. So the bottom of the fraction is x minus 6, and I set that equal to 0, and then I get the equation x minus 6 equals 0. To get rid of that minus 6, I'm going to add 6 to both sides, and I get x equals 0 plus 6, which is just 6. Now, since this is the equation of a line, x equals 6, it's going to be a vertical line. That's why it's called vertical asymptote. You just leave your answer as x equals 6. So this is not an ordered pair. This is an actual line. So asymptotes are always going to be these lines that the graph cannot cross, but they get infinitely close to, which is pretty cool. So that vertical asymptote is x equals 6. Notice that when x equals 6, by the way, the denominator would be 0. And why is that? It's because if I let x be 6, I get 6 minus 6 in the denominator, and that's going to give me 0. You can't divide by 0 in the denominator. So that's why the values of the function start to go crazy once you get to x equals 6. Okay, horizontal asymptotes. So what I want to look at this is, I want to compare the degree of the numerator to the degree of the denominator. So let's say that the numerator is a of x. I want to compare that to the degree of the denominator. Let's call that b of x. Okay? Now, if you don't know, degree is basically the highest exponent in the polynomial. So if you're looking at the top of the fraction, the highest exponent is 1, and that's the same way on the bottom. The highest exponent is 1. So you have a 1 right here, a 1 right here. So now these two sides are equal. So if the degrees are ever equal, you want to find the leading coefficient of the top, and you want to divide that by the leading coefficient of the bottom. And when you look at leading coefficients, these are these big numbers out in front of the variable. And since they're both 1 this time, we have 1 over 1, and that's going to give us y equals 1 divided by 1, which is 1. So that's our horizontal asymptote. Now for oblique asymptotes, we really don't have any here, because if you want to have oblique asymptotes, you have to have a specific type of, let's say rule that applies to the top and the bottom. See, if you want to have an oblique asymptote, this has to be satisfied. The degree of the top of the function has to be equal to 1 plus the degree on the bottom of the function. But since these two degrees are equal, we're not going to consider any oblique asymptotes for this one. So this is going to be none, since these are not equal. Okay? And then for point discontinuities, that's the last thing that we talk about. We really don't have any point discontinuities on this function. And that's because we don't have any points that are missing. Now, how do we know that? Well, you could graph it and see it, but you could also think there are no canceled factors. There are no canceled factors. So you don't have to worry about any factors being crossed out or anything like that when you factor it, because this is already in simplest form. You can't factor it down and do anything to it. So since there's no cancel factors, there's not going to be any point discontinuities. Okay? Let's look at number 3. Number 3 is h of x is equal to x plus 3 on the top, x plus 3 on the top, and on the bottom we have x squared plus 8x plus 15. That's quite the denominator. Now we can simplify this by factoring the bottom. The top is just going to stay the same because you can't really factor anything out of x plus 3. Well, I guess you could take out a 1, but there's no point in doing that. What we want to do is we want to factor the bottom by finding two numbers that multiply to 15 but also add up to 8. So what two numbers will multiply to 15 but at the same time add up to 8? That would be 3 and 5. So I get x plus 3, x plus 5. It's that simple. Okay, so we factored the bottom. Now, are there any common factors on the top and bottom that we can cancel out? Yes, the x plus 3's. So I crossed those out, and what I'm left with is nothing at the top, so I put a 1 as a placeholder. But then on the bottom, what's the only thing I have left? X plus 5. So now we're going to do all of our math on this simplest form right here, this 1 over x plus 5 that we have. So the first thing I can do is I can find the zeros. And the way I do that is I set the top equal to 0. Well, when I do that, I get 1 equals 0. Does that make any sense to you? Of course not. So there are no zeros. This graph is never going to cross the x-axis. Okay, how about vertical asymptotes? We can set the bottom equal to 0 to find those. So I get x plus 5 is equal to 0. Now what can I do to it? I can subtract 5 on both sides to get the x by itself. And then when I do that, I get x equals 0 minus 5. That would be negative 5. So that's our vertical asymptote. Horizontal asymptotes, what about those? Well, let's compare the degree at the top to the degree on the bottom. What is the degree of a of x, the numerator? And what is the degree of b of x, the denominator? Well, the numerator is 1, so we're finding the degree of 1, literally. And the denominator is x plus 5, so I got to find the degree of x plus 5. So what's the highest exponent right here? Well, it's going to be 1. But what's the highest exponent when you just have a number? Technically, if you just have a number, the highest exponent is 0. That's the highest power because there are literally no x's, right? It's just a 1. So that means that we have a situation where we have a less than. 0 is less than 1. So what I'm going to do is I'm going to go back and I'm going to fill in that less than symbol. Okay, so what does it mean if the degree at the top is less than the degree of the bottom? Then, if you follow your rules for horizontal asymptotes, you'll know that your horizontal asymptote is going to be y equals 0, the x-axis. Y equals 0, also known as the x-axis. Okay? So now do you see why there are no zeros here? Why there are no x-intercepts? It's because the x-axis is an asymptote, right? And it never crosses the asymptote, so it's obvious that it's never going to cross the x-axis. That's why there's no zeros. All right, let's do oblique asymptotes. Well, for this to be true, you're going to have to see if the degree of the top is equal to 1 plus the degree of the bottom. And thankfully, that is not true, because I get 1 plus 1 equals 0, which is kind of impossible. 0 is not equal to 2. So I'm going to cross out the equal sign here and here. So there are none. There are no oblique asymptotes. Okay, the last one that I want to look at is point discontinuities, because that could occur with this one. And the reason why we have a point discontinuity is because we have a canceled out factor right here. Notice that we canceled out the x plus 3 on the top and the x plus 3 on the bottom. Therefore, we have to set that equal to 0. So I get x plus 3 is equal to 0, which gives me x equals -3. I probably skipped a step in there, but we have a point discontinuity at x equals -3. All right, and then the last one I wanted to discuss was number 5. So let's try that one. Number 5 is g of x is equal to x minus 7 over x squared minus 49. X squared minus 49. Okay, so the top cannot be factored. It's just x minus 7. But the bottom is difference of squares, because we have an x squared and we have a 49, which, as you know, is a perfect square. So I can factor the bottom as x plus 7, x minus 7. So I get x plus 7, x minus 7. And it doesn't matter which order you put the plus and the minus, because you're going to get the same result regardless. The top is still x minus 7. So now, since we have a common factor, we can cancel out the x minus 7s, and we're left with 1 over x plus 7. That is the rational function that we want to look at and do math on. Okay? So let's find the zeros by setting the top equal to 0. I get 1 equals 0, which of course is no good, so there are no zeros. I write none. Vertical asymptotes. Now I set the bottom equal to 0. I get x plus 7 equals 0, which gives me, after a little bit of math, x equals -7. So that's going to be my vertical asymptote. What about horizontal asymptotes? Well, we have a situation where the degree of the top is less than the degree of the bottom. Less than the degree of the bottom. So my horizontal asymptote is going to automatically be y equals 0. Okay, oblique asymptotes. Well, is this true? Degree of a of x is equal to 1 plus degree of b of x? No, can't be true. So there are none. Point discontinuities. Let's take the canceled out factor and set it equal to 0. Remember, we canceled out the x minus 7s, because they were common factors on the top and the bottom. So I set x minus 7 equal to 0, and then when I solve it, I get x equals 7. So I know there's going to be a point discontinuity at x equals 7. So those are the odd ones on the test. I hope that helps, and I hope that gives you a guideline as to what you're going to be looking for when you do these rational functions and what to solve for.